let's recapitulate a small fact about centripetal force and why we are discussing it in friction. First of all, what do we know about centripetal force? This is the necessary force which is required by any of the body to keep in a circular motion, right? So as we have already discussed the circular motion, in case of circular motion thing, that centripetal force is always provided by some external force. For example, if a body is tied with a string and it is rotated, then the required centripetal force is provided by the tensional force. Second, if an electron is revolving about the nucleus, then the required centripetal force for the necessary action, that is provided by the electrostatic force of attraction. Similarly, in case of planets and satellite motions, the orbital motion of planet, that is provided by gravitational pull of sun. So everywhere centripetal force is always provided by some other force. Now, what is banking of tracks? See, during a circular path, when you normally drive a vehicle, you would have often seen that roads sometimes bend in circular way. Or example, for about roundabouts, you take a vehicle around a roundabout, the circular path, there you have to lower down the speed of your vehicle, right? So why is that required? And the banking of tracks means, see, normally a straight road is horizontal, but sometimes due to geographical topography of the area, the higher curvature of road is not possible to construction. So what we do, we construct a level on the road, that is, the road is banked, so that is called banking of tracks. So let's discuss it with proper equations why banking of tracks is necessary. First of all, we are considering a case of normal circular path. This is a road where there is a vehicle coming about, okay, and it's taking a circular turn. Suppose this is our vehicle. What are the forces right now acting on the vehicle? So first of all, weight of the vehicle vertically downwards, so the normal reaction will be on the vehicle exactly opposite. At this time it will be mg. Now since the body is taking a circular motion, there must be some radius of the circular track about which this whole curvature is happening. So along that radius there will be a centripetal force which will be acting on the body. And which other force? I have just told you that centripetal force is always provided by some external force. So at this point, which is the force which is providing the necessary centripetal force required for the circular motion? This is the frictional force which acts between tire and the road. This is the frictional force which is applying, which is actually providing the necessary centripetal force at this moment. So what do you think? Which value must be greater? The value of, this is the formula, we have already discussed about this formula. This is the formula of centripetal force. So the centripetal force must be what? Less than or equal to the frictional force. That means if this is the force, the friction is the force which is providing the necessary CF. So the value of frictional force must be greater than or equal to this. What is frictional force? This is, frictional force is mu r. What is normal reaction at this point? mg. So this becomes this. This mu is the coefficient of static or kinetic friction. See, at any instant of time there is a static friction, right? So you can take it mu s. Now this m cancels out and you are left with v square should be less than equal to r, or I should write it mu r g, right? So what would be the maximum, or I can write it like this, v value must be less than or equal to mu rg. So maximum velocity with which a vehicle can take a circular curve is this. This is the maximum value under root mu rg. R is the radius of circular track, which I have taken by small letters. Let me change this. This is small r. This is the radius of track. So this is the maximum velocity by which the vehicle can go about a circular path. If the velocity increases, then the friction force won't be able to stop the vehicle in going along the tangential path or outside, which is causing the or along the centrifugal force. So the vehicle will skid from the road and it will go off the track, right? That might cause accidents. Now in such cases we can see the maximum velocity is dependent only on radius, rest two are constants. So what if we are not in a position to construct that much radius? See, to increase the value of velocity, suppose I am driving from Delhi to Gurgaon to increase the value of velocity, I have to make this value large so that the vehicles can go at a larger velocity, right? But what if due to geographical location we cannot construct that much circular path? So in that case, we lift this whole part of the road up in an inclined way so that there is an angle between horizontal and the road, which is called banking of tracks. That is why the banking of tracks is required, which we'll just discuss.